Hello and welcome back to Dr. Logic Awkwardly Does Logic. This is it. It's finally the time. We're finally here. I'm going to prove to you that S5 is complete with respect to the class of frames that are reflexive, transitive, and symmetric. That means that any modal formula that is valid in this class of frames, you can prove in S5. So we've already done all of the heavy lifting to prove this theorem. Everything in the last, I don't remember how many videos that is at this point, has been leading up to proving this. So this is our theorem. S5 is complete with respect to the class of reflexive, transitive, and symmetric frames. So let's call this class CS5, just so that I've got something to call it. Another way of stating this theorem is that if on the class of frames CS5, some formula phi is valid, then you can prove it in S5. So how do we demonstrate this? Take an arbitrary formula which is valid in the class of reflexive, transitive, and symmetric frames. We don't care about the things that aren't valid. We already know that we can't prove them because the system is sound and we can't prove things that are invalid. So we're going to take an arbitrary formula, which is valid in this. Then we had our first lemma that we proved 2 videos ago, which says that if phi is valid in the class of reflexive, transitive, and symmetric frames, then phi in ordered modal conjunctive normal form passes the test. And then we've got the lemma that we proved in the previous video, which says that if phi in ordered modal conjunctive normal form passes the test, then we can prove it in S5. And not only that, but I gave you the method for actually generating the proof. So if you take these two things together, we've got on the one hand, if phi is valid in the class of frames, which it is by assumption, then it passes the test. But if it passes the test, then we can prove it. So by these two lemmas, we know that in S5, we can prove phi. So this is what I mean about all of the heavy lifting already having happened. We did all of the work in identifying ordered modal conjunctive normal form, doing all of the reductions, showing that you can always do this, proving lemma 1, constructing the test, showing how to apply the test, lemma 2, generating the proofs and everything, so that in the end, it follows this result immediately from these two lemmas. So there you are. Now, this is a proof of the completeness of S5. It is not the proof because there's more than one proof. This particular method, as I've said a number of times, only works for this particular system. We need to be able to do things like reduce to first degree. We need to be able to have ordered modal conjunctive normal form, all of these things. We don't have this for every single modal language. So you might be sitting here thinking, what if I want to prove the completeness of something else? What about S4 or T or some weird combination of axioms that I haven't even ever seen yet? Well, lucky for you, I'm going to give you a generalized method that you can use for proving the completeness of a whole bunch of classes of different modal logics. It's not going to be a general procedure, but it will get you probably like 85% of the ones that you actually care about. And then in future videos, we can go on and do some of those weird extreme cases. Not quite yet. In the next video, what we will do is actually walk through this entire procedure from start to finish, from an arbitrary modal formula all the way to determining, is it a theorem of S5 or not? So join me then, or skip that video if you don't care, and jump straight to the one after that, which is when we'll start doing the general method of completeness for a wide class of modal logics. Until then, take care. Cheers.